Okay, so this time I've got for you guys a few, I guess, less than normal looking linear equations. We're going to jump into this first one here. So we've got 4z over 5 minus 8 is equal to 4. Okay, my best approach on this one is to isolate this variable. So the first thing I'm going to do, I'm actually going to add 8 to each side. And what that's going to do, that's going to cancel this whole side here for me, make it nice and easy for me. Now I'm dealing with just 4z over 5, and that equals 12. So I've still got this quotient here on the left-hand side. So the way I'm going to look at getting rid of that, I'm going to multiply this side by 5, which means I'll multiply this side by 5 as well. I've now got 4z is equal to 60. And from here, this is looking a fair bit easier for me. I'm just dividing both sides here by 4. And I've got z equals 15, which is my final answer on that one. Okay, so for this next one we're going to look at, we could go ahead and distribute to start with, but if you look on this side we've got 2, and on this side we've got 6. So we can actually go ahead and actually divide both sides by 2. And that makes things a little bit more easy to look at. So I've only got 3 outside of a minus 3 on this side. I think I'm going to have to distribute this now. So let's leave the 10 minus a by itself. We've got 3a, and 3 times negative 3 is negative 9. When I look at this, I see I've got a positive a over here. I'd rather have all my positives on one, or all my pronumerals on this side in this case, because the 3 is going to be a lot bigger than the single a on this side. So I'm going to do 2 steps here at once. I'm going to add an a to this side, which means I have to add an a to this side over here as well. And I'm also going to, at the same time, get rid of this constant on the other side. So I'm going to add 9 here, which means I also have to add 9 on here. So my right-hand side is the 4a, because that was the whole point. And again, over here, that was the whole point. And we've got 19. So my final step is to divide both sides by 4. So we've got a equals, well, 16 is 4 plus the 3/4 remaining. So here's our third, it's still a linear equation, but because of these fractions it makes it look a lot harder than it actually is. But if we understand how to add and subtract fractions, we can just treat these as just standard rational numbers, even though we've got these variables in here. So as you'd know, to subtract any rational number, we need a common denominator. And I'm going to include the this denominator of 4 and look for the LCM of 5, 3, and 4, just to make my life easier, and I'll show you why in a second. It will all come clear. And unfortunately, the LCM of these numbers is actually the number 60, but so let's work towards that. So I'll write it again, and I'll have a bit more room this time to include these changes to the denominators. The first term here, okay, so I need to get that number 5 up to 60. The way to do that is I need to multiply by 12. If I do the same thing to the top, I'm only multiplying this whole idea by 1, so I'm not actually changing the number. Here's our next one. And again, I've got 3. I've got to get that up to 60, so I'm going to multiply that by 20 on 20. And my final term is 15 on 15. You'll find that 20 is 5 times 4, you'll find that 15 is 3 times 5, and you'll find that 12 is 3 times 4. So let's neaten this up. So on this side here, I'm just going to put the 12 on the 12 times the 3. I'm going to keep it distributed for now. That way it's a bit easier to move around and to deal with. So 3 times 12 is 36. Leave my product in here. Over here, 80, 4 times 20 is 80, x times 2, x minus 2, over 60, and over here I've got 45 on 60. So my whole point of this, and particularly including this 3/4 on the end here, was if I multiply this side here by 60, so this is my first actual algebraic equation step. I'm doing the same thing to both sides. I'm going to multiply this side by 60 as well. And by design, I've now just got 36, 3x plus 4, subtracting 80x minus 2 equals 45. So something a lot more simpler for me to deal with, and I don't have to worry about those rational numbers anymore. Let's just go ahead and distribute out these factored terms. So 36 times 3 is 90 plus 18, so 108x, and 36 times 4 is 120 plus 24, so we are adding to 144. Negative 80 times x is negative 80x, and negative 80 times 20 is positive 160, and this equals 45. Here's another equation step. I'm going to get rid of this 144 on this side. I'm going to get rid of this 160 as well at the same time, which means I have to do the same to the other side of the equation. So I'm going to subtract here by 304. When I simplify and gather my like terms here, I get 28x, and this is equal to, this operation here ends up with negative 259. So from here it's a walk in the park now. 28, divide by 28 on both sides. Go ahead and use your calculator. Try to leave the answers in a rational, even a mixed number format would be the way to go. Much easier to deal with in algebra than decimal numbers in the future. So yeah, I hope you've enjoyed these 3 examples of linear equations, not just your average run-of-the-mill, something a little bit different.